This question doesn't say similar or similarity anywhere in the problem, but it is to do with similar triangles. You have the small triangle I've drawn in blue and the big triangle in red, and because they share an angle, they are similar. So you can treat the ratios of the lengths as it's the same length ratio wherever you are in the diagram between any pair of corresponding sides. So I'm going to just write that down, length ratio. There's no area and volume in this one. It's not like we have to do any squaring or cubing, but just out of force of habit, I'm going to write length ratio because it is to do with length, and that is 6 to 13.5. So I've spotted that we have a common side. We know that the base of the small triangle is 6 and the base of the big triangle is 13.5, and there's no other common value that we know for each of the for the two triangles. We're trying to find in part A the length of AB. So that's this one here. So that's the small version of the 11.7. So I'm going to write 11.7 on the big side of the ratio. And now, if you've got a class whiz bang calculator, then there's a ratio function which will just work out this missing value here. I've got a separate video on that. Look in the comments for a link to that. If you have to do it manually, you just need to do this calculation here. I've written 11.5, sorry, that should say 11.7, divided by 13.5 times 6, and that gives you 5.2. So AB is 5.2 centimetres. Now to find ED in part 2, that's this bit. Now that's not part of a triangle. It's not one of the sides of a triangle. But look, if we know A to D and we take away this 4, then we've got ED. So let's just try and find AD, which is the big version of this side, which is 4 for the small triangle. So again, our length ratio is 6 to 13.5, and I know the 4 corresponds to the small triangle, so I put that on the small side. And again, you can use the class whiz to get the missing value, but if we just do 4/6 times 13.5, we get 9. So AD is 9, and therefore ED is 5 centimetres.